Hello, hi everyone. Welcome to the class. So now we will discuss about human eye in colorful world. Human eye and colorful world. So human eye is the most sensible, sensitive organ in our body. Human eye is the most sensitive and sensible organ in our body. Okay. So with human eye only, we can able to see the beautiful world in front of us. Okay. So with thank you so much. So thank you so much. So now we'll discuss about human eye in colorful world. So human eye in colorful world. Let's start. So here you can see. Okay. Human eye and colorful world. Human eye and colorful world. Colorful world. Okay. So in this, now we will discuss about human eye parts and function first. Human eye parts and function. Human eye parts and function. Okay. So now we'll draw the human eye diagram. Human eye diagram. Understood? I will draw the human eye diagram. Then after that we will discuss about their parts. So after that we will discuss about parts and function. So let's start here. So how to draw the human eye? Okay. So simple way, easy way we can draw. Simple way, easy way we can draw the human eye. Just check once here. So I'm taking here. So like this. Okay. So complete round circle you can take it. Okay. So this is the cornea. This is the cornea. This is the cornea. So I'm drawing the islands. Now I'm drawing the islands. This is the islands. This is the islands. Okay. Islands. Whenever light rays falls on it, that is called so I'm drawing the, you can observe. Okay, so front layer protect a layer of the eye. So you can observe like this. So this is the optic now. Optic now. So cornea. This is the cornea. And next one iris. This is aqueous humor. Aqueous humor. And coming to the iris. Iris ciliary muscles. Ciliary muscles. Ciliary muscles. Okay. So next one eye lens. Next one we can say eye lens. So eye lens is the eye lens or convex lens or crystalline lens. Whenever light rays falls on it, it converts the light rays and make it falls at retina. Okay. And coming to this one is the pupil. And next one is the eye lens. And next one vitreous humor. Next one retina. Optic nerve. So these are the parts. So cornea, aqueous humor, iris, pupil, eye lens, ciliary muscles, vitreous humor. Okay. So here you can observe. Understood? So human eye. This is the human eye. So cornea is the frontal layer, protective layer of the eye. Most of the refraction takes place at cornea. Okay, when light rays enters, so at this portion, most of the refraction takes place at this part. This is the cornea. Okay, coming to aqueous humor. Aqueous humor is a jelly type liquid present between cornea and eye lens. Okay, so and coming to the iris. Iris is a dark muscle. So this part and this part is also iris only. So we can say this portion also iris only. And this portion also ciliary muscles. We can say these are the ciliary muscles. Understood? Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. Okay, people will control and regulate the amount of light entering into the eye. People will control and regulate the amount of light entering into the eye. Okay, and coming to the next one, ciliary muscles. When you want to see the nearby object, as well as far distance object. If I want to see the near, normally in mobile what we'll do, we'll zoom out or zoom in to see the nearby object as well as far distance object. But in our eye, automatically we can able to see nearby object as well as far distance object. Okay, so eye lens, ciliary muscles will adjust the curvature of the eye lens. Ciliary muscles will adjust the curvature of the eye lens so that eye lens will adjust its focal length to allow the light inside of it. So the ability of the eye lens to adjust its focal length is called power of accommodation. Ability of the eye lens to adjust its focal length is called power of accommodation. Whenever light rays coming inside, so ciliary muscles will adjust the curvature of the eye lens, so eye lens can adjust the focal length so that it can allow the light inside of it. Okay, so with the help of ciliary muscles, it can eye lens can adjust focal length so that by that we can able to see the nearby object as well as far distance object. Understood? So that is about ciliary muscles. Coming to eye lens. Eye lens is a convex lens. Whenever light rays falls on it, converge the light rays and make it falls at retina. Make it falls at retina. Okay. So next one we will discuss about wet ray shimmer. Wet ray shimmer is a jelly type liquid present between here. Entire portion is filled with wet ray shimmer. Wet ray shimmer between eye lens and retina. Entire portion is filled with wet ray shimmer. Wet ray shimmer is a jelly type liquid present between eye lens and retina. Eye lens and retina, so it provides sufficient force and pressure, okay, so to maintain that shape. Coming to the retina, it is a light sensitive screen. There are two cells are there, those are rods and cones. Okay, two light sensitive cells are there, those are rods and cones. Rod sense the intensity of the light, cone sense the color of the light. First one is rods. Rod sense the intensity of the light, cone sense the color of the light. Okay, rod sense the intensity of the light, cone sense the color of the light. Understood or not? So rod sense the intensity of the light and cone sense the color of the light. So there are two light sensitive cells are there at retina. So what type of image will form at retina? Real and inverted image will form. That too 2D image will form. That will convert in the form of electrical signal that will reach to the brain through optic nerve. Okay. So that 2D information is nothing but, so we will only get 2D information. That too real and inverted image will form at retina. That will be converted in the form of electrical signal that will reach to the brain through optic nerve. Understood? Through optic nerve. Okay, so how far it is, how much distance it is. Okay, so how much it is filled, everything that additional information will be given to the brain. Okay, so brain will add that additional information so that we can able to understand, right? And coming to the optic nerve. So optic nerve, this will carry the electrical signals to the brain. I hope it is very clear. So that's enough. That is about cornea, aqueous humor, iris, pupil, lens, ciliary muscles, wet ray humor, retina, optic nerve, and rods and cones. Okay, so I hope it is very clear. These are the points. Now we will discuss about refractive defects. So before that, we will discuss about near point and far point. Okay. So near point and far point we will discuss. Near point and far point. Near point. Near point is nothing but the minimum distance up to which a person can able to see clearly without any strain. Okay, that is called near point. Okay, so first one is near point. The minimum distance up to which a person can able to see clearly without any strain. So that is called near point. Coming to the far point, the maximum distance up to which a person can able to see clearly without any strain. So near point is 25 centimeter for normal healthy person. Far point is infinity. Near point is 25 centimeter. Far point is infinity. Okay. The range of vision is 25 centimeter to up to infinity. So if you take any object, so very close to your eye, So if you place the object very close to the eye, so we can't able to, so if you place this object very close to the eye, very close to the eye, so we at a certain time, sometime you can see, so normally you can see, but after a certain time what happens, our eyes will get strain and pain, our eyes will get strain and pain, so that we can't able to see over long distance, over a long distance. I hope it is very clear. Okay, I hope it is very clear. So that is about near point. So below that one we can't able to see. At 25 centimeter only we can see. So far point is infinity and range of vision is 25 centimeter to infinity. 25 centimeter to up to infinity. I hope it is very clear. That's enough. And coming to the next one, so when a person is the person is standing in the bright sun, suddenly it enter into the cinema screen, so he can't able to see the object immediately. So whatever the objects are present in front of him, so he can't able to see immediately because cellular images can't contract beyond certain point. Okay, so it immediately it won't expand. Okay, so it won't allow the light inside of it. It will take certain time to adjust with the light. Okay, in bright light, so it's required very less light is required to see the object. When you enter into the dark room, okay, when you enter into the dark room, so you need more light to enter to see the things. So immediately it can't adjust. Okay, cellular modules can't adjust, so immediately, so it will take certain time to adjust with the light. Understood? So due to that reason we can't able to see, so sometime. Alright, so I hope it is very clear. So that is next point. And coming to one more, that is near point, far point is completed. Next one, refractive defects. What lens has to do, normally whenever light rays falls on the lens should refract the light rays in order that those light rays will meet at retina. What if lens does not refract the light properly? So what happens if light is not refracted by the lens properly? Then what happens? Those light rays will not meet at retina. So there is a defect. So we can't able to see the object. So based on the refractive defects, so these defects are called refractive defects. So based on the refractive concern, so refractive defects, there are three are there. So those are, one is myopia, hypermetropia, presbyopia. There are three refractive defects. One is myopia, hypermetropia and presbyopia. Coming to myopia is nothing but the person can able to see clearly near point, he can't able to see the far point. The person can able to see clearly near point, he can't able to see the far distance object. For the correction of myopia, we are using concave lens. So which lens we are using to correct the defect of myopia? Concave lens. Okay, concave lens. So myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So we can able to see near distance object, you can't able to see the far distance object. For the correction of myopia, we are using concave lens. I will draw one diagram, just show it. So check here. So I am taking this a point. Okay, so here you can observe this the 25 centimeter and this one is the infinity. The person can able to see near point 25 centimeter, but he can't see the far distance object, infinity. But in between 25 to infinity he can see. So here you can observe, so from this point we can able to see, so we can able to see this one, but we can't see the far point, for that what we will do, so we have to correct this one, draw the diagram. So I am taking like this. So this is a far point, this is a near point, near and far. So if the light rays are coming from far point, okay, if the light rays are coming from the far point, those light rays will meet at retina. So that we can able to see the objects. Okay, so I am taking here. So this is the far point of myopic eye. Far point of myopic eye. Okay, coming to the myopic eye. Okay, so let's coming to the myopic. Okay, so just check once here. Okay, so this is the near point and far point. If the light rays are coming from infinity, those light rays will meet in front of the retina. Okay, so check once here. So I'm taking the light rays here. Now you can observe. So these dotted lines. Okay, so here I'm taking, here also I'm taking. Those light rays will meet in front of the retina itself. Okay, those light rays will meet in front of the retina. Okay, so here this is the myopic eye. Understood? Myopic eye. So coming to the next one, you can observe myopic eye. So the light rays are coming from this point. From far point. Okay, so which lens we will use to correct the defect of myopia? Concave lens. So we will use concave lens to correct the defect of myopia. So I'm using concave lens. Check once here. So this is a concave lens. So this is the near point, and this one is concave lens. Okay, concave lens we are using to correct the defect of myopia. So concave lens. So 1 lighter I am taking. Thank you everyone. Those are supporting, thank you so much. So here you can observe those light rays will meet here at retina. So do like, share and subscribe to Student the Brand. Inform to your friends, ask your friends to join to the class. So regularly, daily we'll be having live classes. Okay, so inform to everyone. Classes will go on continuously without any breakage. Okay, so here you can observe what is this lens we used? Concave lens. What is the lens we used? Concave lens. Concave lens. Understood? So this one is this is a correction of myopia. Correction of myopia. Correction of myopia. So you can check the textbook, you can check any reference books. So you can check this concept. So with any reference book you can add later, then you can ask me if any changes are there, then I will answer. So here this is the far point of myopic eye. Far point of myopic eye. So this concept you have to remember. This is the concept. If the light rays are coming from the far point, those light rays will meet at retina. Okay. And here you can observe if the light rays are coming from infinity, that is infinity, those light rays will meet in front of the retina. So that's why we can't able to see the object, those light rays are coming from infinity. Understood? So by using concave lens, here you can observe focus. So far point, far point, far point. Okay, at the end also the dotted line should meet. Okay, so wherever you are taking dotted line, those dotted lines you have to bring back to the far point. Okay, so like this you have to draw the diagrams. Like that you have to draw the diagrams. Far point of myopic eye and correction of myopia. So by seeing the second diagram, you will get to know the causes. If you observe this second diagram, you will get to know the causes. Causes. So you will get for 2 marks. Causes. So what are the causes? Causes. Eyeball is too long. Eyeball is too long. Focal length is too small. Eyeball is too long. Okay, because so focal length is small. Eyeball is too long. Focal length is too small. So these are the causes of myopia. Okay. So just observe the concept, understand the concept, draw the diagrams, understand the concept. That's enough. If you understand the concept, then you can able to draw the eye diagrams very easily, okay, without any much struggle. So you first understand the concept. So the person who has myopia can see nearby object, but can't see the far distance object. But between 25 to infinity he can see. That is a far point of myopic eye. If the light rays are coming from the far point, those light rays will meet at retina. So we can see that is a far point of myopic eye. And coming to the next one, so myopic eye. So myopic eye is nothing but if the light rays are coming from infinity, those light rays will meet in front of the retina. So it is a defect. Those light rays are meeting in front of the retina only, right? In front of the retina. So there is a myopic eye. And coming to the next one, correction of myopia. So by using concave lens, we can correct the defect of myopia. Understood? So first, second, third, and max sometimes they will ask about correction diagram. So they will ask about this diagram, correction diagram. So draw the correction diagram of myopia. So you have to draw this diagram. Understood? So you have to draw this diagram. So this is about myopia. And coming to the hypermetropia. So hypermetropia. Next one is hypermetropia. Hypermetropia is nothing but the person can able to see clearly far distance object. Hypermetropia is nothing but the person can able to see clearly far distance object, but he can't able to see the nearby object. So if the light rays are coming from nearby object, he can't able to see. Those light rays will not meet at retina. But between 25 to infinity, so nearby, so in between that point he can able to see. If the light rays are coming from between 25 to infinity, so those light rays will meet at retina. Understood? So now I'll draw the, okay, so this is the concept. Once check this concept, then you can understand. So this is the 25 centimeter and infinity. He can see infinity, but he can't see the 25, but somewhere in middle between 25 to infinity he can see. So that is the near point of hypermetropic person. Near point of hypermetropic person. Okay, if the light rays are coming from near point, so this point, those light rays will meet at retina. If the light rays are coming from 25, those light rays will meet beyond retina. So how it will be? So I'll draw the diagram, check once. So here you can check. So I am considering this eye diagram. I am taking like this. Okay, so this is the lens. Eye lens I am taking. So the light rays are coming like this. Okay, so this is the near N. This is N. And this one is the N dash. N and N dash. So if the light rays are coming from N dash, those light rays will meet at retina. Okay, so you can observe these light rays are coming from N dash. Those light rays will meet at retina. Okay, so you can observe, check once here. So these light rays. Okay, so you can observe this one. You can observe this one. So this is the near point of hypermetropic eye. Near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. Coming to the hypermetropic eye. So how to draw the hypermetropic diagram? So dear students, try to share to everyone. So support the channel, inform to everyone, inform to all the students, ask them to join to the class. So do like, share and subscribe to Student the Brand. Okay. So here you can observe. So here. So here N is 25 centimeter, N dash is near point. So N dash is the near point of hypermetropic eye. N is 25 centimeter. Okay, so this is very very important. So you have to understand one thing. N is 25 centimeter. N dash is the near point of hypermetropic eye. Near point of hypermetropic eye. Okay, so if the light rays are coming from, so I'm taking like this. So if the light rays are coming from 25, those light rays, 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 those light rays. So those light rays will meet beyond retina. Myopia concave lens. Already I did the diagram also. Oh, thank you so much. Please share to your friends. So inform to everyone. So ask your friends to join to the class. Share as much as possible. So please support the channel, encourage the channel. Okay. So support the channel. So inform to everyone. Ask them to join to the class. If my content is good, my explanation is good, please share to everyone. Okay, so this the hypermetropic eye. Hypermetropic eye. So daily hypermetropic eye. Daily live classes will be there. Daily live classes will be there. You can join to the classes. You can attend to the classes regularly, continuously. So throughout the day, live classes will be going on. Just inform to your friends. Ask your friends to join to the class. Okay. So ask them to join to the class. Listen to the class. Share to your friends. Share to your friends. Inform to your friends. So thank you so much. Thank you for supporting. Okay, so here you can observe. So here I am taking the lens. Here I am taking the lens here. Like this. Ask them to join to the class. Ask them to join to the class. So which lens we are using? Convex lens. So which lens we are using? Convex lens. Convex lens. Convex lens. Convex lens. Okay, so inside already it is there convex lens. Outside also. Okay, so now this is the near point and this is N dash. So if the light rays are coming from N, those light rays are meeting. So here you can observe and here you can observe. So you can see. So those light rays will meet here. Okay, so like this I'm taking. And these light rays also, this will meet at retina. So you can observe. And here also. Okay. So N dash. N dash. This is N and dash. So this is the correction of hypermetropic eye. Correction of hypermetropic eye. Correction of hypermetropic eye. Hypermetropic. Correction of hypermetropic eye. Understood or not? So one check this one. One check this one. First one is the near point of hypermetropic eye, and this the hypermetropic eye. If the light rays are coming from 25, those light rays will meet beyond retina. And coming to here, if the light rays are coming from this point, by using convex lens, we can correct the defect. We can correct the defect of hypermetropia. Understood? So the correction of hypermetropic eye. So next, so we will discuss about so next one, these are presbyopia. Presbyopia is nothing but the person can't able to see so near point as well as far distance object. Near distance object he can't see, far distance object also he can't see. So for the correction of presbyopia we are using bifocal lens. Upper portion is concave lens, lower portion is convex. Upper portion is concave, lower portion is convex. Okay, so that is about bifocal lens. And coming to the next one, cataract. So a milky and cloudy layer will form on our eye. So if you observe, okay, when we are aging, so when we are aging, a milky and cloudy will form on our eye. Okay, so by using cataract surgery, so we can able to remove that layer. Okay, so next one, astigmatism. Astigmatism is nothing but the person can't able to see the horizontal lines as well as vertical lines. The person can't able to see, identify the horizontal lines as well as vertical lines by using suitable cylindrical lens. So that defect can be corrected by using suitable cylindrical lens. That astigmatism defect can be corrected. Okay, so next one, refraction through prism. So we'll discuss about refraction through prism. When light ray passes through the prism, how it will be. So we'll see. So here if you are taking this a prism, when light ray passes through the prism, so here it split into 7 colors. The splitting of white light into 7 colors. 1, 2, 3, 4, 5, 6, and the last one is 7. Okay, so 7. So those 7 colors will form like a band on the screen. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Those 7 colors will form like a band on the screen. Okay, so now like this. So you can see, yes, astigmatism. Okay. So like this you can observe. Okay, so like this if you take, so violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. VIBGR. Violet, indigo, blue, green, yellow, orange, red. VIBGR. Understood? And the next one. So next one if you are taking through water droplet also we can say. Actually Newton sent the white light through prism. It split into 7 colors. Still further he want to split the colors. So he placed the normal prism near to the first prism. So but he couldn't get anything. So that's why. So what he did, he placed the inverted position of the prism near to the first prism. He placed the inverted position of the prism. So this is the inverted position of the prism like this. So he placed like that. Okay, so those 1, 2, like this. Understood? Those 7 colors combined and comes out as a white light. So on the screen it is white light. On the screen it is white light. So okay, this is violet and red, violet and red, violet and red, violet and red. So this is the source. This is the source. This is the white light ray. White light. Okay. So this is the prism 1 and prism 2. So light ray passes through the prism. So it's split into 7 colors. Okay. Again those 7 colors will fall on the second prism. Okay, those 7 colors will fall on the second prism. Those 7 colors will be combined and comes out as a white light. Okay, comes out as a white light. Okay, next one. So we can see rainbow in the sky. Rainbow in the sky, right? Rainbow in the sky. How it will form? What is the phenomena involved in the formation of rainbow? What is the phenomena involved in the formation of rainbow? So here you can observe. So this is the water droplet. This is a water droplet. Water droplet. Water droplet. Water droplet. So light ray passes like this. Light ray passes. Those light rays will split into 7, and those 7 colors will comes out as a white light. Okay, so here you can observe. So here this is a white light. White light. Okay, so violet and red, violet and red, violet and red. Okay, so what is the phenomena involved in the formation of rainbow? Refraction. Refraction. Second one is dispersion. Refraction, dispersion. And third one is internal reflection. Refraction, dispersion, and internal reflection. Internal reflection. Okay. Internal reflection. Internal reflection. So I hope it is very clear. So when light ray passes through the prism, it's split into 7 colors. The splitting of white light into 7 colors is known as dispersion. Okay, those 7 colors will form like a band on the screen, that is called spectrum. So recombination of spectrum of white light. This is the recombination of spectrum of white light. Recombination of spectrum of white light. Spectrum of white light. And here rainbow formation by water droplet. Rainbow formation by water drop. Understood? So that's enough. Once again observe here. So violet, indigo, blue, green, yellow, orange, red. So recombination of spectrum white light. And coming to your rainbow formation by water drop. Understood? I hope it is very clear. So these are the points. And next one, coming to the atmospheric refraction. Refraction takes place by the atmosphere. And that is called atmospheric refraction. Refraction takes place by the atmosphere. That is called atmospheric refraction. Atmospheric refraction. Understood? So now stars appearing twinkling due to atmospheric refraction. Stars appearing twinkling due to atmospheric refraction. And one more point, advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset are due to atmospheric refraction. Advanced sunrise and delayed sunset is due to atmospheric refraction. Means, so 2 minutes advance and 2 minutes delay. So how it will happen? Just check once here. So I am taking this the earth. This is the earth. Okay. So earth atmosphere. This is the earth atmosphere. I am taking the earth atmosphere of the earth. Atmosphere. Okay, so this is the origin, this is the origin. The sun is below the origin. Okay, the sun is positioned below the origin. So this is the origin here. This is the origin, sun. So normally it appears here. Okay, when light ray is coming from the sun due to, so the person is here, due to atmosphere, so scattering of light. So due to atmosphere, refraction of light takes place. So here is the, so here is the sun, here is the sun, here is the sun. Okay, so after that, so the sun position appears here. This apparent position of the sun. This is the actual position of the sun. This is the apparent position of the sun. This is the actual position of the sun. Due to atmospheric refraction, okay, due to atmospheric refraction, the sun position appears above the origin, So above the origin. Okay, above the origin. So actually it is below the origin only. Due to atmospheric refraction, the sun appears above the origin. Understood? So this is due to atmospheric refraction. So twinkling of stars is due to atmospheric refraction. Sir, why stars twinkle? Why planets do not twinkle? So planets are minute sources of light. So one place it is dark, one place it is bright. So the total effect will be nullified. That's why planets do not twinkle. So coming to that, scattering of light. So next one we will discuss about scattering of light. So actually atmospheric refraction, when light ray coming from sun, so due to atmospheric refraction takes place. So actually it is below the origin. Due to atmospheric refraction, it appears above the origin means 2 minutes advance. And evening time also, so 2 minutes already sun down, but still it appears in the sky 2 minutes delay. Okay, so 2 minutes advance sunrise and 2 minutes delay sunset. Okay, that is the reason. So next one, scattering of light. Scattering of light. So what is scattering of light? Scattering of light is nothing but, so scattering of light is nothing but the re-emission of light in all directions with a different intensity. The re-emission of light in all directions with a different intensity. So here you can see, so this is the particle, the light is coming and falling on it. Okay, this is a light ray which is falling on it. So we know the wavelength, So you can observe this is the wavelength of the particle. So wavelength. So that this is the crust, trough. So the distance between two consecutive crust is called wavelength, and the distance between two consecutive trough is called wavelength, and the distance between. Okay, so the distance between two consecutive crust or two consecutive trough is called wavelength. Understood? So when light is incidenting on the particle, the wavelength of the light which is incidenting on the particle is comparable to the, yes ma, it is 10th class CBSE grade 10 physics. CBSE, so you can see at the top, CBSE grade 10 physics. Okay, so now you can see the wavelength of the light, which is incidenting on the particle, the wavelength is comparable to the particle size. Okay, na? So the particle will absorb the light. That particle will absorb the light and emit in all directions. So the light ray, so the particle will absorb the light and emit in all directions with a different intensity. So when the wavelength of the light is comparable to the particle size, then particle will absorb the light and emit in all directions with a different intensity. Okay. So that is called scattering of light. Sky appears blue color. So remaining time, and during morning time and evening time it appears reddish color due to scattering of light. So red has longer wavelength, it travels long distance in the morning and evening. So in the morning and evening, okay. So the distance is more compared to the remaining timings. That's why whenever light rays enters from the sun, so remaining all colors will scatter. Only red color travels long distance. Okay, that is the reason it appears red color during morning time and evening time. And coming to the remaining time, it appears blue color due to, so the shorter wavelength scatters the most. Okay, so the scatter wavelength, the light scatters the most. So according to Rayleigh principle, okay, so scattering of light is inversely proportional to fourth power of the wavelength. So if wavelength is less, scatters most, like that. So blue color has shorter wavelength, so it scatters faster, at the same time more. That is the reason it appears blue color. Sir, okay sir, what about noon time? In noon time it appears white. But as soon as light enters, so those colors scatters equally in all directions. Then again, all colors will be mixed, comes out as a white light. So you can observe, yeah, in lower classes we painted all colors on the Newton disc. Okay, if it is mixed, all the colors, so all colors will if you rotate, then it appears white color. Okay. So that's enough. Next one, we are going to discuss about one more, that is scattering of light is completed. Next, Tyndall effect. So Tyndall effect is nothing but, so the path of the light becomes visible. Okay, when light ray passes through the colloidal solution, so due to colloidal particles, so light will scatter equally in all directions. When light ray passes through the colloidal solution, due to colloidal particle, the light will scatter equally in all directions. So equal in all direction. Okay, in all directions. So scatter light in all directions. So that's why we can able to see the light. So at that point, if you send a laser light through lemon solution at that position, so the laser light appears very bright because scattering of light takes place by the colloidal particles. So if you open in the morning time, early morning, once you open the window, so a light beam of light falls on the ground. Then in that beam, the dust particles are flying. You can observe dust particles are flying, right? So due to scattering of light, and even when you move on the road, so a narrow beam of light falls on the ground, right? So if you are moving, so in middle of the trees like this, so on the road in exactly, so many trees are there, so exactly one narrow beam falls on the road. So in that narrow beam you can able to see the dust particles are flying. So this is all due to scattering of light. So the path of the light becomes visible when it is passing through the colloidal solution. So this is about Tyndall effect. Understood? So right from starting human eye in colorful world, so each and every part like human eye parts and function, refractive defects, myopia, hypermetropia, presbyopia, cataract, astigmatism, and refraction through the prism, recombination of spectrum of white light, rainbow formation by water droplet, and next one, atmospheric refraction. So advanced sunrise and delayed sunset. So advanced sunrise and delayed sunset will come for 3 marks, and upper end position of the sun appears. That only the advantage and delay center. So that question will come 3 marks, and recombination of spectrum of white light it come for 3 marks, and coming to the rainbow formation by water droplet that also comes for 3 marks. So myopia, hypermetropia, in that compulsory one question. So diagram based related question will come for 5 marks, and causes will ask 2 marks, and MCQs also very important. For MCQs point of view, I parts and function you have to learn compulsory without any doubts. Okay, so this is about human eye parts and human eye and colorful word, and all the points we discussed. So if you have any doubts you can let me know. So thank you so much for joining and attending and listening my class. So inform to your friends, share to your friends. Daily live classes will go on. So live classes only will go on. Interaction classes, live classes will go on. If you have any doubts, you can type in the comment section. So by seeing the question, I will respond to the question. Okay, so you no need to wait and ask, just type a message and drop in the comment section, then I will, so I'll see that question. If it is related to concept, definitely I'll answer to the question. So if it is next to the question, according to that I'll answer. Okay, so please do like, share and subscribe to Student the Brand. Inform to all your friends, ask your friends to join to the class. So click on like button, share, and so if you like the content, if you like my explanation, please do like, share and subscribe. Thank you so much. This is our Shiva sir from Student the Brand. Thank you. See you soon in the next class.